everyone, I'm Kristel and Celemin from the Pampanga State University, Alangilan Campus, taking Bachelor of Science in Information Technology from the section 2105. This video is all about the compilations of the activities in Chapter 8. So let's start with the first activity. So activity, calculate the subnet mask basic. So the instruction is, in this activity, you are given a subnet mask in decimal format. Enter the binary representation of the subnet mask in the octet fields provided. Additionally, convert the mask to prefix /x format in the prefix notation field. So what we will do is to make the subnet mask into binary. So these are the given subnet mask. So we will put here all the answers in binary, and then this is the prefix notation. So the first one that we will convert is the 255. Since we have the position of the 1, 2, 4, 8, 16, 32, 64, 128. So that is an 8 octet. So if we add all that number, the 1, 2, the 4, 8, 16, 32, 64, 128, that will have a sum of 255. So that's why we will all put 1. So it will be 8, 1. So 1, 2, 3, 4, 5, 6, 7, 8, 1. The same also here, the 255. So it also 8, 1. So next one is the 255 also, then 8, 1. This one is the 248. So we will convert the 248 into binary. So the next one, the first that we will do is we can put 1 in the 128 because the 248 is greater than 128. So 248 minus 128 is 120. So we can put 1. So our remaining number is 120. So the next number is 64. We can also use 64 because it is less than 120. So we will put 1. The remaining number is 56. So the next number is 32. So we can use 32 because it is lower than 56. So we will put 1. The remaining number is 24. So our next position is 16. So we will put 1 because 16 is less than 24. So we'll put 1. So we only need 8. So the next number is 8. So we will put 1. So to sum that all position that has 1 will sum of 248. So we need 8 binary numbers. So the last number will become 000. So next that we will do is the prefix notation. The prefix notation we'll get this by, we will just count all the 1 here. So that is 8, 16, we have the 8, 16, 24, then 25, 26, 27, 28, 29. So we have the 29. Then to write that, we have to put forward the // then the 29. So let's check if our answers are correct. So correct, you have correctly converted the subnet mask to binary and prefix notation formats, please click the new number to continue. So let's try another one. So just like we did, this is the next number. So 255, just like what we did. So it's all 1. Then all here, and then also here. Then the 252. The 252 is what we convert to binary. So we can see that 255 and 252 has only 3 difference. So we can conclude that we can put 0 in the 2 position and the 1 position to have a 2 for a 3 difference. So we can put 1, 2, 3, 4, 5, 6, 7, 8. So we have the 6, 1. The 6, 1 will have a total of 252. So the remaining will become 0. Then for the prefix notation, we'll count all the 1. It will be 8, 16, 24, 25, 26, 27, 28, 29, 30. So forward slash 30. Let's try. So correct also. Then we will now proceed to the next activity. So this is the next activity. Activity: determine the number of bits to borrow. Instruction: in this activity, you are given the number of hosts that are needed. Determine the subnet mask that would support the number of hosts as specified. Enter your answer in binary, decimal, and prefix notation format in the fields provided. So that for 25, it will all 1. Then will all 1, and then 1, 1, 1, then 0, 0, 0. So it also has an 8-bit. So 8. Then here, the 255. So we will count all the 1 here for the prefix notation, just like what we did in the previous activity. So it is 8, 16, 24, 25, 26, 27. So it has forward slash 27. Same as this one. So the 1, 1, 1, 1, 1, 0, 0, 0. And then 0, 0, 0, 0. Then we will count all. It's 8, 16, 17, 18, 19, 20, 21. So forward slash 21. It's right here. Right. This one, and so we will count all the 1s. It will become 8, 16, 24. So it has 20 or 25. Then there. Then 240. Then forward slash 26. So we will just, in prefix notation, we'll just count all the 1 here. Then 8, 16, then 23, because it only has 1 0. Then let's check if our answers are correct. So correct, you have correctly determined the subnet mask and entered it in bit or in binary, decimal, and prefix notation format. So it's like we convert it into this binary, we convert it in here as 255, also here and here, and all this binary we to have this answer the subnet mask, we just use this binary to convert. Then the prefix notation. So we will now proceed to the next activity. This is the next activity. Activity part 1, practicing VLSM. So instruction is table 1 uses regular subnetting to accommodate the network shown. Table 2 uses VLSM to further subnet the network. Drag the addresses to the appropriate subnet description. So this is the table 1. So calculate 50 users per subnet. So the first is new subnet mask in decimal. So the first is 192. Then first prefix notation, it is the forward / 26. So it starts here. First full subnet range. Subnet range is this one. 192.168.5.4 up to 192.168.5.63. So the next one is second full subnet range. So we can see here that the last in the first full subnet range is the 5.63. So we will that second full subnet range is the 192.168.5.64, that 192.168.5.127. Then this is the last. Let's check if our answers are correct. So correct, you have correctly calculated the subnet. So now we will proceed to the second part of this activity. So activity part 2, practicing VLSM. So instruction is table 2 uses VLSM to further subnet the network. Drag the addresses to the appropriate subnet description. So the first is second full subnet range forward / 26 from table 1. So that is the 192.168.5.64 up to 192.168.5.127. The next one is new VLSM subnet mask in decimal. So this is the 255.255.255.224. The next one is VLSM prefix notation. That is the forward / 27. Then the first full VLSM subnet range. So it is the 192.168.5.64 up to 192.168.5.95. Then last full VLSM subnet range is the 192.168.96 up to 192.168.127. So let's check if our answers are correct. So correct, you have correctly calculated the subnet using VLSM. So that's all for this video. Thank you for watching.